Let's start on page 178. Now, I've only got one target, but that's a bit misleading because there's a lot of things in this target. Know and use, so know what the theorems and postulates that we're going to talk about say and be able to use them to solve problems. The corresponding angles postulate. Hey, we talked about corresponding angles yesterday, learned how to identify them. The alternate interior angles theorem, we talked about those yesterday. Consecutive interior angles theorem, talked about those, and the exterior angles theorem. So we're taking what we learned to identify yesterday, and we're going to do something with them. All right? So know what these this postulate and these theorems say, be able to use this postulate and these theorems to solve problems. We start with the corresponding angles postulate. It says, if two parallel lines are cut by a transversal. Now, in geometry, we like to use this word cut. It means intersected by. Okay? Cut means intersected by. So if two parallel lines are intersected by a transversal, then each pair of corresponding angles is congruent. All right, since there are four pairs of corresponding angles, there will be four pairs of congruent angles. So look, angle 1 corresponds with angle 3, doesn't it? Because they're both above the transversal to the left of their own lines, and the lines are parallel. I almost forgot to say that. All of this postulate and these theorems for today, they all deal with parallel lines being intersected by a transversal. Yesterday, were the lines parallel? No. Now they are. And now that the lines are parallel, we have some special things that we need to notice. So, since the lines are parallel and they're cut by a transversal, then each pair of corresponding angles is congruent. So angle 1 is congruent to angle 3. Angle 2 and angle 4 are a pair of corresponding angles. So angle 2 is congruent to angle 4. Angle 7 and angle 5 are a pair of corresponding angles. So angle 7 is congruent to angle 5. And angle 8 and angle 6 are a pair of corresponding angles. So angle 8 is congruent to angle 6. Is any of this true if those two lines are not parallel? None of it. Okay? The lines must be parallel, then we conclude that corresponding angles are congruent. Okay? If the lines are not parallel, then none of those pairs of angles will be congruent. Okay? Well, look, that's kind of handy, isn't it? So, let's say we knew that the measure of angle 1 was 120. What's the measure of angle 3? Now, don't forget things we already know, such as vertical angles are congruent. Angle 1 and angle 7 are a pair of vertical angles, correct? They're congruent. So what's the measure of angle 5? What's the measure of angle 8? 60, because linear pairs are supplementary. What's the measure of all the rest of them we haven't labeled yet? Yeah. So once we know 1, we got all the rest. Now let's look. You guys are smart, right? Let's see if we can figure something else out. Alternate interior angles theorem. Don't look in the book. Look up here. Look at these alternate interior angles. That's a pair of alternate interior angles. That's a pair. What do you think our alternate interior angles theorem is going to say? Yeah, that if two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. Okay? Look at the alternate exterior angles. What's that theorem going to say? Yeah, if the lines are parallel, the alternate exterior angles are going to be congruent too, aren't they? Not this one, though. Consecutive interior angles. There's a pair of consecutive interior angles. They're not congruent. What are they? Yeah, supplementary. What about these? Supplementary. All right, so let's take a look at these other theorems. The alternate interior angles theorem. If two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. We have parallel lines, transversal. So there's one pair of alternate interior angles. So angle 1 is congruent to angle 3. There's your second pair of alternate interior angles. So angle 4 is congruent to angle 2. Then we look at the consecutive interior angles theorem. If two parallel lines are cut by a transversal, then each pair of consecutive interior angles is supplementary. So the measure of angle 1 plus the measure of angle 2 has to equal 180. And the measure of angle 4 plus the measure of angle 3 equals 180. With me? All right. And then the last one, the alternate exterior angles theorem. If two parallel lines are cut by transversal, then each pair of alternate exterior angles is congruent. So angle 5 and angle 7 are one pair of alternate exterior angles. So 5 is congruent to 7. And angle 8 is congruent to angle 6 because they are the other pair of alternate exterior angles. Questions? Now, know the names of the theorems because these theorems are pretty lengthy to write out. If we run into questions like we had previously where they say to name the theorem that justifies your answer, we don't want to write the whole theorem out, do we? And plus the names pretty much make sense, don't they? The postulate that deals with the corresponding angles is called the corresponding angles postulate. The theorem dealing with alternate interior angles is called the alternate interior angles theorem. All right, so the names, I think, make sense. All right, questions before we work some problems? All right, let's do some. And let's see, what page is this from? Page 181. In the figure, the measure of angle 1 equals 94. Find the measure of each angle. Tell which postulates or theorems you used. Go ahead and draw this on your paper so we can write on it. Okay, now I'm tempted to just fill in all of the angles at once, but I'll go one problem at a time just so that I can kind of keep straight which postulate or theorem I'm using. Number one, they want to know what the measure of angle 3 is. What's the measure of angle 3? 94. And which postulate do we use? We use what now? Corresponding angles, and this is the one that's the postulate. This is the one that got us started. It's used to prove the others. Number 2, they want to know the measure of angle 5. What is the measure of angle 5? Yeah, it's 94 as well. What theorem did you use? Yeah, you could use the vertical angles theorem because we know the measure of angle 3 already, or you could use the alternate exterior angles theorem. Does it really matter which one you put down as your answer, as your justification? No, it depends on how you thought of it. So I'll put them both, vertical angles theorem, alternate exterior angles theorem. And you can abbreviate the same way that I do. And then we need the measure of angle 4. What is the measure of angle 4? 86. So, measure of angle 4 equals 86. And how do we know? I'm looking at a linear pair. Is that what you guys are looking at? Like, either those two make a linear pair or those two make a linear pair. So we can write out linear pairs are supplementary, or do you remember the name of the theorem that says if two angles form a linear pair, then they're supplementary? The supplement theorem. So either way, either write it out, linear pairs supplementary, or supplement theorem. Any questions? All right, let's keep going. In the next set of problems, this time they say in the figure, the measure of angle 4 equals 101. Find the measure of each angle. Tell which postulates or theorems you used. So, go ahead. Do 4, 5, and 6. Everybody get 101 for the measure of angle 6? Yeah, I just did the alternate interior angles theorem since I already knew the measure of angle 4. For number 5, everybody get 79 for the measure of angle 7? Yeah, and I did the supplement theorem. Is that the only way I could have done it? I didn't have to. I could have figured out the measure of angle 5 using the consecutive interior angles theorem and then the vertical angles theorem. Okay? And number 6, I got the measure of angle 5 to also be 79. And a couple of ways I could have done that. Since I already knew angle 7 was 79, I could have done vertical angles theorem. Instead, I chose to say that I was using the consecutive interior angles theorem because angle 4 and angle 5 have to be supplementary. So, looks like quite often there's more than one correct answer to the which postulate or theorem you used, doesn't it? Okay, so that's okay. All right, we still doing okay? All right, number 7. In the diagram, the guardrail is parallel to the surface of the roadway, and the vertical supports are parallel to each other. Find the measures of angles 2, 3, and 4. All right, so let's see here. Well, that doesn't show up very good, does it? Can I make that fatter? No. Maybe that'll show up better. All right, the guardrail is parallel to the roadway. By the way you mark that lines are parallel to each other is you put arrows, not at the ends to show that they're lines, but somewhere within the drawing of the line, that means they're parallel. And then the guardrails are parallel. So let's see. That one parallel to that one. All right. we know that one of these angles is 93. So let's look here. All right, since, in fact, let me do this. All right, since the two pink lines are parallel to each other, the black one is the transversal. So if this angle's 93 degrees, what's the measure of angle 2? All right, so we got the measure of angle 2. Okay, now let's look at it this way. Since the two black lines are parallel to each other, the pink line is the transversal. If the measure of angle 2 is 93, it's going to take us a couple steps. What's the measure of angle 3 going to be? 87. I did it in 2 steps. I thought, all right, corresponding angles postulate, that's 93. Then I thought, linear pair, that's got to be 87. That's the way I thought of it. Does that make sense? Measure of angle 3 equals 87. And then look, angle 4 is way down here. Okay. Let's take a second. We'll get there, right? Let's see. Let's look at these two with this as a transversal first. This isn't the only way to look at it, okay? This is just a way. Alternate interior angles are congruent, so that's 87, since angle 3 was. And now, if I ignore all this over here and look right here, that's 87 because of the corresponding angles postulate. That's a way of looking at it. Do you follow me? So what's the measure of angle 4? All right, so much for number 7. Now let's try some that involve some algebra. So find the value of the variable in each figure. And then the explain your reasoning, that's probably going to be we just tell what theorem we use. We'll see how that needs to be done in a second. Well, not any real algebra here for number 8. What's the measure of x, or what's x have to equal? Yeah, it has to be 125, doesn't it? All right, because this angle and this angle form a linear pair, so according to the supplement theorem, they're supplementary. So x equals 125. The supplement theorem will be my explanation. All right, if x is 125, what's y? 125. And what theorem did I use there? Alternate interior angles theorem. All right, so 8 wasn't much of a challenge. Maybe 9 will be. We can only hope. All right, on number 9, we're still trying to find the value of the variables, or variable in this case. What kind of angles are those? Are they corresponding? Alternate interior? Alternate exterior. And according to the alternate exterior angles theorem, since this line is parallel to this line, and they're cut by a transversal, what must be true about the alternate exterior angles? They're congruent. Now, sometimes we forget to emphasize the hypothesis of all these theorems. The hypothesis is the if part. The lines have to be parallel. So be careful, because wouldn't it stink if all of a sudden they threw in a couple of lines that weren't parallel and we just assumed that they were? Trust me, it would. We'd be assuming things we can't know, because what are we supposed to never assume? Measures. So you got to make sure that you know the lines are parallel. I've not been emphasizing that as I should have for all these others. You must know that the lines are parallel for any of this to work this way. Got it? Okay. So what's x equal? And we used the alternate exterior angles theorem. Well, maybe number 10 will be harder. For number 10, this one right here is the 2x minus 15, and this one right here is the x plus 55. And what do we know about those angles? Identify them. They're alternate interior angles. And since the lines are parallel, what do we know about the alternate interior angles? They're congruent. That means that 2x minus 15 must equal x plus 55. So I can go ahead and explain alternate interior angles theorem. Subtract x. Add 15. I got 70. What'd you get? Okay. And we do have one other theorem to talk about. Okay. It doesn't really fall under the learning target. It says a special relationship occurs when the transversal of two parallel lines is a perpendicular line. In a plane, if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other. And this is called the perpendicular transversal theorem. I don't really feel the need to know this as a separate theorem. The book obviously did. And like I pointed out before, sometimes you make a theorem just because it comes in handy later on, proving another theorem. And I don't know. It's been a long time since I did real math. I've been teaching high school for 100 years. But isn't this basically the corresponding angles postulate? All right, if, as we've said, the little perpendicular symbol means right angle, means 90 degrees. So if that means 90 degrees there, and it means 90 degrees there, doesn't that make sense because of the corresponding angles postulate? In other words, if that symbol wasn't here, but we knew those lines were parallel, we knew that was a 90-degree angle, wouldn't we then conclude, because of the corresponding angles postulate, that that's a 90-degree angle? So, if the transversal is perpendicular to one of those parallel lines, it's perpendicular to the other of those parallel lines. Okay? Questions? Here's your assignment. On page 181, do 1 through 19, 24 through 29, 38, 39, 47 through 50, and 52 through 54.